Hi, I'm Van Riper from the Google Developer Relations team. I'm the program manager for our Google Developer Groups, which are local meetups run by the community. We have over 300 of them in 95 countries to date. And I'm kicking off this, what we call the Google Developer Groups, the GDGs, all hands, monthly kind of intro to various product areas with a talk from Pete LePage from the Google Chrome Developer Relations team. I want to thank Peter Lubbers from the Chrome team as well as Louis Gray, who's also in the studio here with me in Mountain View for Google Developers Live for the infrastructure to do these kind of talks. And now I'm going to turn it over to Pete in our New York office.
Awesome. Thanks very much, Van. It's awesome to be here. And thanks for getting everybody together to talk about Chrome apps. I think it's a really exciting evolution of some of the stuff that we have, and I think it's something that a lot of the Google developers are going to get really excited about, because it means that you can build apps that look and feel native on your desktop, just using HTML and web technologies. So why don't we jump in? I've got a couple of slides that I want to walk folks through and show a few things as we go, so that you can get a little bit of an idea of what's going on with Chrome apps, how you can use them, and really why they're so cool. So let's start by having a look at a couple of the key points about Chrome apps. So there's a couple of four things we're going to cover today. First, we're going to talk about how Chrome apps break out of the browser. They don't feel like web apps anymore. They now feel like they're installed native apps. The second thing we're going to talk about is the enhanced user interface. So how you can really take all of the stuff that you're used to using today and really be able to make a really beautiful user interface that looks and feels like a native app without, looking like the stuff that you see on the web today. We'll talk about how these apps work offline by default. This is one of the coolest things I think about this new Chrome packaged app platform. It means that your apps work offline by default. Everything that you're used to being able to have with offline apps, just right there. And then finally, we'll talk about some of the new APIs. Things that you can do with these Chrome apps that you just simply can't do with the drive-by web, right? Drive-by web is a great place, but do you really want to open up things like USB or networking APIs in case somebody gets access to them in some not so nice, not so friendly kind of way? So I think the best thing to do is actually to start off and have a look at a couple of demos. So I've got here on my computer a couple of things running, and of course I always do this. You move your mouse to the wrong place and you kick your screensaver in, so let's not do that again. And so I'm going to bring up Chrome. In fact, the slide deck that we're looking at is a Chrome app as well. But the ones I want to take a look at are here already. So today with Chrome apps, they're being launched from the new tab page. In the future, they'll get launched either from the taskbar or from a launcher, but right now we're still in a little bit of an early phase, and so I'll bring one up. So this is a weather app. It's telling me that here in New York it's 45 degrees and a high of 50 today. I want to point out a couple of things though. Notice that there's no address bar here. There's no look and feel that this looks like a native or a web application. I can move it around. I can, interestingly, close it using a different close mechanism. It doesn't have the typical on this Mac that I'm using, the X, the minus, and the plus sign. But you can have those experiences if you want. I'll bring up a calculator. And again, these are just a couple simple examples that you can have a look at. But notice the calculator does have those pieces. Again, no address bar or anything like that. If I wanted to be so brave, I could go turn my network off. So my Wi-Fi is off. If I start the calculator again, sure enough, it works. It behaves exactly like I expect it to. There's no real need for a network connection. I can say on this 1 + 1 = 2. Woohoo! So we know that our math works, right? Okay. One of my favorite and I think more interesting apps right now is something that one of the guys on the Chrome DevRel team worked on, and it was a Markdown app. We'll talk about why this is kind of cool in a sec, but I wanted to sort of show you a couple other things. I can go create a new file. I can open a file. I can save it or print it. So I'm just going to go here and I'm going to open this file, grab this markdown file. So one of the things to notice is I can open files anywhere on my desktop. And sure enough, so here's the file, and we've got two pieces here. We've got the left-hand panel here, which has the markdown, and the right-hand panel that shows the actual markdown rendered into HTML. The really neat thing is that you can edit this on the fly, live in real time. So I can do things like, oh yeah, I just only want that as 1 or 2. So you've got the ability to be able to go and edit markdown in real time. One of the neat things about this is it's actually using Node in the back end to do the compilation and convert the markdown into HTML and render that HTML in the application. So let's close this guy, and I'm going to bring my Chrome app back up along with my slides, and let's go and move on a little bit and take a look at a couple of the points in here. So we saw the demos, a couple of these. Let's talk first about what it really means to break out of the browser. So when I talk about breaking out of the browser, one of the big things that I'm really talking about is that they're launched from outside the browser. Now today, unfortunately, we don't have that in today's Chrome build, but the plan is that you'll be able to go to the Start menu, you'll be able to go to the dock or wherever you launch your applications, and you'll be able to go and launch those apps without having to go and do anything crazy. It's not like you have to open the browser. And that's a really important thing, because users think about the web as something that only works when they're connected. These apps work when they're disconnected, when they're not necessarily on the network. So getting them out of the browser is a really important thing so that there isn't a level of confusion there for some users. The other thing is that these apps have a same first-class feel as other OS windows. So that means you can Alt-Tab between them, you can go in and you can see the apps that are running in your task list. They have that same look and feel that you expect from the native application. In terms of the enhanced user interface, there's a couple of neat things that we've seen some of these already. You've got full control over multiple windows. In a web app, really, well, you can pop open a new window, but typically it'll get blocked by a pop-up blocker. Or if you go to do something where you just don't expect certain behaviors, you may have that stopped in its tracks. And because you've got that address bar, you really have that concept of that single window. You also have full customization of the frame without the browser Chrome. You notice when I brought up a couple of those apps earlier, we didn't have the address bar, we didn't have the browser frame, we didn't have the things that you typically expect out of the web. Links open in a new tab so that if I go and click on this link, sure enough, it opens in my browser. Now it's not going to open anything because I've disconnected myself from the network, so let's go ahead and turn the network back on. And we'll go back to the slides here. So the links open in the app, not the browser. The third point is that these apps work offline by default. They work offline by default because they use the same packaged app experience that we have in the current packaged app system, where all of the resources, the HTML, the JavaScript, the CSS, all of the images sit locally on the user's computer. So when they click install, it really is installing everything that they need to be able to run this app. Just like when they click on install for any other native application, whether they get it, install it through a CD, whether they install it through an app store or whatever, that app runs locally because all the resources are sitting on the user's machine. We also enforce separation of some of the client UI and data. We do that because the client UI is sitting on the computer, and we need to go get that data from the network somehow. So either through making XML HTTP AJAX requests, or maybe you've got some other way of getting data into the user's machine. for example, in the Markdown app, where I just opened the file locally, hit File Open, and sure enough, I was able to load the data from there. The APIs are also something really interesting. We're providing a bunch of new APIs that are available that will provide new functionality. So things like being able to access USB and networking and Bluetooth. But we're also providing a set of APIs that will do things like provide analytics or user authentication. Right now, if you try and go authenticate a user and they're disconnected from the net, it's going to be a little bit hard to do that, right? So the important thing here is that we want to make sure that these APIs degrade gracefully so that you don't have to go and handle the oh crap, how do I do this? How do I go and make sure that my behavior is right? It's really important to make sure that we do this right. And then finally, again, I'll come back to this one, but again, the apps are launched from outside the browser, removing that confusion from folks going, oh crap, I'm on the web right now, so I'm using my browser, that means this isn't going to work, or it is going to work. The experience just works because users are launching the app from outside of their browser. Now there's a whole bunch of new APIs, and this is an area that is tremendously exciting. There's so many neat things that I think developers are going to be able to do with this. First, there's a set of system APIs that are going to allow you access to the system that you've never had access to before through the web. You always had to go and either write a native app, or maybe you had to go and write some kind of plugin, or some other experience that just wasn't a lot of fun for us to do. I like writing JavaScript. I don't like writing C++. I don't like writing Java. I want to write my apps using JavaScript. So by giving access to system APIs, we can do that through JavaScript. Some of the new system APIs that we're giving access to include things like USB. So if you plug a USB device into your computer, you can access those devices. You can send commands to them. You can get interesting data back and forth from them. One of the things that the team's been working on is getting a Connect to work so that you can use the Connect as some kind of input to your applications, that you can turn that into a gaming input for web games. Something pretty slick, really neat to be able to do. We've got networking APIs. In fact, one of the networking APIs, there's a couple of them. There's TCP send and receive, and there's also UDP send and receive. That means you can open up a port and work as a server. You could write a web server within a browser, which is a little bit meta, but kind of cool, right? Like you actually get the browser being able to serve stuff. You can also send TCP requests and send TCP data over the network. So for things like the new Philips Hue, those new lights that are controllable via networking, you can actually go and control those through a web application. I've seen things like IR controllers that work over TCP. So you send a TCP connection to the IR controller, and then the IR controller sends out an IR blast. Maybe it turns your TV on, maybe it turns your air conditioner on. Whatever the case is, you can go through and be able to get that. There's also a set of shared data APIs. Shared data APIs allows us to very easily go in and say, hey, I want to be able to store data on the user's computer, or be able to load data from alternate sources. If you're a Chrome user, you're used to being signed into your browser probably, and love the fact that Chrome remembers who you are and your usernames, passwords, your bookmarks, all that kind of stuff across all the different devices that you're on. Well, with these shared data APIs, as an application, we can also store data, our application data, in the Google Cloud, so that when I sign in on my computer, it works just fine. But if I then go switch to another computer and sign into Chrome, start this app up, all of that data is all synced down, just in the same way that it was if I had used my own computer. Finally, there's a set of service APIs that we're working on. So these will include things like being able to do Google Analytics, so I can see, oh hey, how many people are using my app, and I can track those kinds of things. Google Authentication, so that I can sign in and validate the users who they think they are, who they say they are. Hopefully they think they are who they really are, because that would be a little confusing. But being able to validate users. And there's a bunch of other service level APIs that we're working on and will be coming over the next little while. The programming model is the same, or very similar to Chrome apps. If you've written a Chrome packaged app in the past, under the current Chrome Web Store, you're already probably 80% of the way there. It's based on that Chrome packaged app where all the resources sit locally. The one thing that changes is instead of having the index file as that first file that gets loaded when the application starts, there's a background page that works sort of as the hub. If you've written any kind of native code, maybe a native mobile app, maybe a Windows or a Mac app, you're used to having that main function body that kicks off the app, that opens that first form or opens that first window. Very similar, and we'll take a look at the code. We're actually going to go and write a Hello World app and take a look at some other examples in a minute. The app lifetime is controlled by the runtime, and it's all event driven, so that you can say, hey, when the app starts, do this, when the window closes, do this. You've got that control and ability to be able to do whatever you need to do. It is single page, and there isn't really that concept of navigation, right? There's no address bar there anymore. So you can't go back and forth between different pages. You can't do those kinds of things. Now you can load different pages, you can open different windows, but the core concept is around that single page application. There are a few web features that are deprecated for a couple of reasons. So things like window.navigation, window.url, because they just don't make sense when you don't have the address bar. There's a couple others, and there's some good documentation on what's gone away and how you can why it's changed, as well as good alternatives for how you can go use some of those things. So let's talk for a moment about the security model. I already noticed a couple questions pop up from people saying, hey, so what about the security model on this? Or like somebody asked, well, what about viruses? Well, the security model is really around process isolation. So that means that applications, your app is running in its own isolated window. So it's sandboxed just like other Chrome apps. You don't have to, and other web pages. They're not going to be able to access other applications' data. They're not going to be able to get into things that they shouldn't be able to get into. But they also have a set of permissions model. That means that applications need to ask permissions before they can do certain things. For example, if you don't have the USB permission, you can't use the USB APIs. If you don't have the networking permissions, you can't use the networking APIs. So we really try to make sure that when a user installs an application, they know what APIs are available and what APIs that the application is being called, so that they can make an informed decision about how to go and whether they want to trust that application or not. Because these apps are running HTML and JavaScript, there really isn't an easy way for viruses in the traditional sense. So it's much more about protecting user data, which actually leads perfectly into the next comment, which is something called content security policy. If you're not familiar with content security policy, there's a great article up on HTML5 Rocks that I'd really recommend you check out. HTML5 Rocks' article on Introduction to Content Security Policy lays out all of the great details. Short description of it: content security policy helps protect applications from cross-site scripting vulnerabilities. So typically when a web app or a website is hit with a cross-site scripting vulnerability, it's because somebody's able to inject a bunch of JavaScript into somebody else's application. So evil bad guy manages to inject some JavaScript into mybank.com, and when I go sign in on my bank, that JavaScript sends my username and password back to his website. So all of a sudden, evilguy.com is able to get stuff that I don't necessarily want to share. Now, the way that content security policy helps to protect web applications from cross-site scripting vulnerabilities is by limiting where script can run and how it can run. So typically, when on any page, if you don't have any content security policy rules in place, you could put script inline in your HTML, you could do evals, you could do all kinds of things that are interesting to do, and typically some of the things that we're used to doing. Content security policy, the rules that are implemented within Chrome apps, limit you from putting any inline JavaScript within your HTML. So that means that you can't do script, close bracket, blah, 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 or like, and put some script in there. You have to link to a script source file. You actually have to put your script into a separate file. We'll take a look at this when we do some of the demos. The other thing that this limits you from being able to do is anything like eval or return new function or any equivalents to that kind of thing. So if you're used to using evals or anything like that, you're going to need to change that process just a little bit. In some cases, some MVC frameworks and some templating libraries do use eval. We're working with some of those templating libraries to try and get them to switch and not use those, but you may run into that issue if you're using any of these things. There's also storage isolation, so any data that you store in for the user's profile doesn't get shared between apps. There's no way to get any additional data. And there's an explicit shared data API, so really limiting some of the stuff. And finally, you don't have access to some of the extension APIs. One, it doesn't really make sense to be able to go grab like the tabs in Chrome, right? Because you're an application that has nothing to do with the browser, even though you're written on web technology. I want to call out one other cool and different thing. There's a web view control that if you want to go and put live web content into your app, you can use this web view control. So you notice there I've got web view and all I do is open web view, provide a source link to that particular place, and it renders that. So that's particularly useful if in your application you want to be running or you want to put ads in your application and your ads are going to get served live or something to that effect. So the web view is just an easy way that you can put live HTML into your application. All right, so I think I've talked too much. Let's actually go and take a look at building our own Chrome app. So I'm going to get out of here, so I'll close this down. And so I've got the basics here in Sublime for what I want to show and what I need. So first off, there's basically 3 steps that we need to walk through in order to be able to write our first Chrome app. So the first thing we need to do is edit our manifest file. So if you've written a Chrome app before and you're used to the manifest file, you've seen it before, or maybe you've written a Chrome extension, the manifest file is very similar. It's basically a JSON file that defines how the application should get its resources, where it should get its files, and all that kind of stuff. So let's go ahead and we'll start. So I'm going to say name and hello there. Alright, so we've defined our name. Next thing we need is a description. Always fun to type live. This is my description. I love it when it auto-completes stuff for me. We need a version number, so I'm going to say, let's call this 0.5. One little hint for folks, as you start to put your apps in, don't go with like version 0.1, because if you upload an app at 0.1, users are going to go look at it and be like, why would I want to install 0.1? That's like before beta. So put a reasonable version number. So our case, seeing that this is only going to be a Hello World app, I think we can safely say this is a 0.9. So the next thing we need to do is define how our app is. And this is another JSON object, and so we're going to say background. And the background is defining what background script that we need to run. So I'm just going to say scripts, and I'm going to give it an array and with just one single item with main.js. And so that's going to say this background script, this main.js, is the file that you want to load immediately. It's like that when you're writing native apps, it's that same thing that's got the application start code in it. Next thing we want to do is add some icons, because it's always nice to have some icons for our app. We want some nice high quality stuff. So I'm going to go and add a 16 by 16 pixel icon, and I'll say image icon 16.png. And I also want to have a 128 pixel by 128 pixel icon. So that way I've got a nice good size image for wherever I need it to show up. So img icon 128. Alright, so there's our icons. I guess I don't need that there. And that's the manifest file. That's everything that I need. The key thing that I want to highlight here is this one piece here, which has got the background script. So let's go ahead and save that file. And the next thing we need to do for step 2 is actually go write our main JavaScript file. So this, again, this is the file that kicks off our application. This is the file that says, hey, we're good to go, and when the app starts, this is the one that we want to use. So let's start here. So this app uses the Chrome namespace, so I'm going to say chrome.app runtime, and we want to add an onLaunched listener, so launched add listener, and function. You know what? I'm just going to move this down so that we can see this. There we go. Function. All right, and pop that guy there. All right, so now inside our event listener, we're going to say chrome.app.window.create, and this is going to go and create a new window with window.html, and we'll define that in a sec. And then we want to provide some properties to that particular window. So I want it to open at width of 400. Helps close that. We don't want that. There we go. And a height of 500. All right. So that's really all we need. So basically what's going to happen now, Chrome's going to listen for when this application is launched. When it's launched, it's going to create a new window using the window HTML file, and it's going to create that window as a 400 by 500 pixel window. So we can go in and we can do the final piece. I'm using Sublime, so I'm going to cheat a little bit, and I'm going to go in and just put in the basis for my stuff. So this is my hello there app, and I've already written a little bit of CSS because I figured you guys didn't want to see me write CSS. It gets a little bit boring. All right, so we'll put our CSS file in there as main.css, and I'm going to put this in as an h1. Hello there, everyone. Let's just do hello there. Hello world. Got to go for the base for the standard stuff. All right. So now I'm going to save that. I'm going to save my main.js file, and I've also saved my manifest file. So those are the three things that you need. Notice that in here I've got my two icons. So the icon 128 and icon 16. I know they're a little small, but you can trust me that they're there. And let's go and grab Chrome Canary. And just to prove that this is all working offline, I'll turn off my Wi-Fi again. And we need to go into the extensions tab. So if you're not familiar on how to get to the extensions tab, I'll just close this so that we can see. You click on the three little guys here, go to Tools, and click on Extensions. And that'll open up the Extensions tab. One thing that you want to make sure that you do is check this little checkbox here, the developer mode checkbox, because that's going to make sure that Chrome's in developer mode. If that's not checked, notice that the load unpacked extensions goes away. So we want to make sure that that's checked. So now I'm going to say load unpacked extensions, and I'm going to go and grab the one that I just wrote. So here it is, pointing to the directory. I'll click select. Haha. All right, so always fun. If there's any kind of problem with your application as you're working on these things, you'll get an error right off the bat telling you, hey, there's something going on here, you're not quite right. So sure enough, I had created a backup directory just in case I had any typos. So I need to go get rid of that. So let's just go and we'll rename this backup directory and we'll call it XXXXXX backup. There we go. So bring Chrome back up. And again, we'll load the unpacked extension. I'll click select. And sure enough, there it is there, hello world. I'll open a new tab, and there's my hello there app, right? So this is the same thing that we saw that we were working on. When I clicked on it, here's hello world. So my app is now up, it's running. All right, success. We have hello world, we're set, we're good to go. Now I want to point out a couple of little things that as you're working on these apps that you can dive a little bit deeper into how to debug these things. So first thing to note is that if you want to go in and bring up the developer tools, well, you can't. Like Control-Shift-J or Command-Option-J, like it's not there. And because there's no browser frame, I can't go and click on the little icons. What I can do, because we're in developer mode right now, and this is an application that I installed myself, I can right-click on this, and I can go in and I can see Reload Page, Reload App, Inspect Element, or Inspect Background Page. So I'm going to go and just say Inspect Element, and sure enough, here's my standard set of developer tools. I can go in and I can do all the stuff that I'm used to being able to do within Chrome's developer tools. So I can maybe go turn off centering. I can go in and I can say, oh, hey, I want to go to the console and find out what's going on some of these things. So you have the full set of developer tools that you're used to being able to use completely within Chrome apps. You can go into the resources, being able to see all the files that are getting loaded. You can see anything else that's going on and know, all right, great, sweet, we're good to go. I'm happy. All right. So let me close this out. And I want to take a look at the code for the calculator. So I'm going to go and grab the code for the calculator. Now, all of this code is available if you want to go and start playing with some of these yourself. The link is down on the bottom of the page. We've got a really phenomenal set of resources that you can go and sample apps that you can go download on GitHub. That's where that link will take you. So I'll go grab the calculator, open this guy up. So sure enough, you can see in the calculator, we've just got a set of divs with some buttons, our controller, which is where our view is. In this particular case, we're using an MVC framework, is right here. I can go in and see my main JS. Now, interestingly, with this main JS, I'll move this down so we can see a couple of these things. So remember how I had window.html. This, you can load whatever file you happen to want. I just put in height and width in my previous example, but in this case, they set both a height minimum and maximum. So that actually means that I can't resize that window. So you've got the same set of experiences as you'd expect to be able to have in native applications. You can go through and you can actually minimize and maximize those things and really be able to do a lot of great things. We've got all of our framework stuff here so that you can go through and see, oh, okay, so this is how we handle all of our application. And then the view for this application. So again, that same thing where everything is all available to you quickly, easily, and you can go through and build some of these out yourself without going into anything too crazy. So with that, what I want to do is open it up to some of your questions that you guys have as we're going through. So I'm going to bring Van up here in a second. Van, you're on screen now, and folks can hear you. I'm going to pop over to some of the questions that I've already popped into Google Moderator. I'm also going to put the link up here. So if you've got questions and you want to ask your questions, you can post your questions to that URL there through Google Moderator. So let's take the first question. And the first question from Rob in Montana, or MT, is, will Chrome apps be available on mobile Chrome? And I'm really excited to say, yeah, they will be. We're still working through some of the implementation. Yeah, this is really cool because it means that you can write your app with the same set of code in one place, and you can get it to work across multiple devices. So not only will it work on a Mac and on a PC and on a Chromebook, but it'll also work on an iOS device and on an Android device. We still have a few details to work through and to make sure that we get this right, because we want to make sure we get it absolutely right. But that's something that we're working on, and expect to see more about that in the next, hopefully, couple weeks. So keep an eye out for that. So the next question, does the Chrome Apps team have any plans to work with any of the mobile team to allow Chrome apps? So I think we just kind of hit that one. The one thing I will call out on the way that we're doing this is that basically we're doing it through Cordova or PhoneGap, so your app will get wrapped in PhoneGap. We're putting a lot of effort and a lot of energy into the Cordova project, the PhoneGap project, to make sure that the project is really great, that it rocks, that the experience is good for us as developers, but as well as for consumers. Now, 90% of our code is probably going to work across devices without any modification, but you will have to remember, like, the screen on a phone is a little bit different than that on a tablet, and is different than that on a laptop or desktop. As well, some of the interactions are different. So you will have to have different code for each app, but the core components of your app will remain the same. Joshua in Fresno wants to know, when's the store going to start accepting Chrome apps? Well, Joshua, I don't have an exact date, but keep an eye on the Chromium blog, blog.chromium.org, because I expect to see an announcement about that sometime pretty soon. We've got all the little stuff together. We're just doing those last little things to make sure that we get everything right. And then we want to hear your feedback. When we do put them up in the store to begin with, it'll primarily be a developer preview. So end users aren't going to be able to go find those apps really easily. They're going to have to go to a particular URL that you'll provide them, because we want to make sure that we don't launch them before they're ready. We want you to make sure that the upload experience is right, that for us the download and install experience is beautiful. So that's I guess that's the answer to that question. Greg wants to know, does the newly created window with frame none property require a user to re-implement all of the standard Chrome window features, including drag to move and reposition? So no, Greg, you're lucky there. You don't have to re-implement that. That was something I didn't show in my demo today, but you saw it in the weather app where it didn't have the standard buttons. If you put frame none, you've got your own set. So when the user drags the app around, all of that stuff, you don't have to go and re-implement that or anything like that. Van, do we have any questions from our live folks before I move on to the next question?
Yeah, Friedger?
All right.
Friedger, are you there? His question is, I think, one of the next ones from Friedger. He's responding right now.
Okay, all right. Well, I'll do the next one, and then we'll come to his question.
Here he is.
All right. Hey.
Make sure you're unmuted, Friedger. Are you unmuted, Friedger?
The fun of live stuff. Well, Friedger works on unmuting. I'll answer this question. What happened to Chrome.WebRequest? It seems to be deprecated in V2. Will it be coming back?
Friedger, are you unmuted?
All right, there we go. Frieder, you have a question. All right, Frieder, we'll come to your question in a sec. I think I see it there on as my next question. So, what happened to Chrome Web Request? It seems to be deprecated. I mentioned earlier that some of the Chromium or some of the Chrome extension APIs have been deprecated. So particularly the Chrome.WebRequest is one of those ones that has been deprecated. You can't get access to that anymore. And there's a couple of things. But keep in mind, you have an entire HTTP or an entire network stack, so you could go make your own web requests if you wanted to. As well, you can use the XML HTTP request, do an XML HTTP request. For the most part, you really shouldn't need the web request extension API because that's for modifying requests that go out on other websites, maybe to do some kind of blocking or maybe adding API or headers and that kind of thing. So you really shouldn't need it. If you do need it, and if you have a particular use case for it, please file a bug at crbug.com. You can go to new.crbug.com and file a bug and say, hey, this is why I need it. Give us those reasons so that it makes it a little bit easier for us. So, Frieder, I know you're joining us a little bit live here. Well, I guess there is no little bit live. You are either live or not. In any event, so what's the security model? I heard someone saying that I could access my NFC reader from Chrome apps. So I touched on this a little bit earlier, but the security model is really around permissions. Does the application ask for permission for this, and then does it use it? So when you install an app, you're told what APIs that are, or what permissions the application, just like you get when you install an app through the Android Play Store. What are the services that this wants? Do you want to allow this or not? And you can say yes, you can say no, and make your decision based on that. NFC isn't something we have access to today, unfortunately, because that's not in most computers. If you had an NFC USB reader, you could probably do it that way, though. So because there's USB access, you can get to it that way. So Van from Silicon Valley. Hey, I know this guy. Do you want to ask your question, Van?
Sure. So I wanted to ask on behalf of all of our GDG organizers out there, I mean, obviously they could show this, this will be recorded and they'll be available later, but are there other resources you could provide that they could use to do local meetups? And I guess this should just be a shout out to everyone to go look at googledevelopers.com/groups, find your local meetup, because hopefully some of these guys will be doing meetups around Chrome apps.
Yeah, that would be really awesome. I just put up a link to our developer documentation. I just put the short link up there because it doesn't really fit on screen very. Hang on, where is it? There it is. All right. But you can also get it at developer.chrome.com, and there's a link down towards the bottom that says Chrome apps. Click on that link, and all of the developer documentation is there. And then the second piece that I think I called this one out earlier was some of the samples. We have about 20 Chrome app samples that are already written, ready to go, that you can go and grab, that you can go through and try yourself. You can install them using Chrome. As well, the slide deck that I used today, there's a modified, slightly older version up there that you can go and, so if you want to run through a similar slide deck, that slide deck as a Chrome app is already up there. So that you've got the slide deck, you've got some demos good to go. You can use this recording as some good talking points. And I expect to see some more stuff. One of the really cool ones, and in fact, I'm gonna stop talking for a sec. Well, I'll keep talking, but I'm gonna show you guys I think a cool video. When we first started working on Chrome apps at Google, or announced them at I/O, one of the things we wanted to do is get it working as with Bluetooth, and one of our guys spent a little bit of time, figured out how to get the Lego Mindstorm kit working with Bluetooth controlled from a Chrome app. So we were doing serial over Bluetooth using the Gamepad API. Well, you guys can see what's up there. So there's a ton of really neat things that you can do with this. So if you're going to have a meetup or a hangout or something like that, I would strongly recommend go find something that you can go play with, kind of like this. One of the other ones that's up there, it's a little bit more expensive to go get, but is absolutely worth every penny, though you'll probably need 2 of them because you'll wreck one, is the Parrot AR drone. We figured out how to control the Parrot AR drone from a Chrome app. So basically it uses UDP network packets that it sends back and forth. So how much fun would it be to start your meetup by flying a helicopter over the audience and controlling it through your computer? Some really cool things that you can do with that.
Anyone that does that, I'll send them a mini banner they can put on their helicopter, GDG banner they can put on that helicopter.
Sweet, very nice. Controlling that helicopter is just super cool. It's one of those really, really fun things. So the next question from Mooseman on the internet, can I build an app with a script that updates files in the package from either my server or the Chrome Web Store? And Mooseman, that's a wonderful question, and a lot of people are sort of going, so if all the resources are sitting here, how do I go get stuff? Or how do I go, maybe I've got some kind of news app where I need to go pull data and I want to pull images and all that kind of stuff. And that's a wonderful question. Yes, you can, and there's a couple of ways that you can do it. One of the ways that you can do it is obviously making XML HTTP requests, AJAX requests to go pull the stuff down, and then you can cache it locally on the user's machine. There's a couple of places you can cache it. You have access to the HTML5 file system APIs, so you can store the files there so that you can just quickly load them right off the file system to be able to render them there. You could also store them in the Chrome storage APIs. I mentioned them earlier. There's 2 of them. There's a sync storage API and a local storage API. You can't store big stuff in the sync one, but you can store some reasonable sized stuff in the local one. Obviously, the local one's not going to get cached between computers. There's also IndexedDB and WebSQL. I'd recommend going with IndexedDB over WebSQL just because IndexedDB is sort of that thing that works across all most places, and it's the spec that's still it's still supported. WebSQL has been a deprecated spec, even though it is implemented in a bunch of other places. So the next question from Hussein and the Colorado GDG in Colorado. Will the new APIs work on Chrome OS and with Chromebooks and Chromeboxes and all that kind of stuff? And absolutely. One of the really important things to us is making sure that these apps work across all devices, no matter whether you're coming in on a Mac, whether you're coming in on a PC, whether you're coming in on a Chromebox. All of these APIs will work across all of these places. There may be a few today that don't work on a Chrome OS machine just because there's a little bit more to implementing them that we haven't finished that stuff yet. But we are working on these things. I do also want to call out that you can start writing these today using Chrome Stable, Chrome Beta. It's also in Chrome Dev and Chrome Canary. My personal setup, so that I've always got a stable browser and a development browser that's sort of on the cutting edge of things, is I keep Beta as my primary browser, and then I keep Canary installed, so that way I can always check to see how things are coming down the pipe. Hussein also wanted to know if Chrome apps are going to be available on Google TV. So because we're going to wrap these as will be available as Android apps as well, I would suspect so. I don't see any reason why not. I've not actually sat down and written a Google TV app before, so I'm not 100% sure on that one, but we'll have a look at that. I'm really impressed with all the questions. There's a ton of really great questions here, guys. This is fantastic. So I'll move on to the next question. will there be apps available for Chrome OS devices to write Chrome apps? So you saw me today using my Mac. I really hope so. That's the one thing I think Chrome OS is missing. And there are a few web IDEs available. And really, now that you've seen that you can build a Chrome app, there's no reason why you couldn't build a Chrome app development environment to write Chrome apps. So it absolutely can be done. In fact, I think one of the sample apps that's up and available on our repository is a HTML text code editor. So I'll go for the next question here from again, another one from Mooseman on the internet. I love on the internet. How do the limitations of access, for example, file system, get user media, differ between packaged apps and apps from a server? So really, there's no difference. If the app needs any kind of permission, you still will either need to ask for that permission, or and that's done through the manifest file. So if you want to get user media, you put the permission request into the manifest file, and then you don't get that pop-up that says, hey, this app wants to do X, because you've already given it permission. So you still have access to the file system, you still have access to get user media, you still have access to geolocation. You don't need to go do anything crazy to do them, you just need to make sure that that request is in your in the permissions section of your manifest file. So next question from Max West. What if you want to make a communication app, something that allows 2 or more users to connect with each other? Great question, Max, and there's a lot of really easy and great ways to go about this. One way that you could do it is using WebSockets, so that you have a server sitting up on your side that you collect all the messages and send them out to the different places, right? So through a WebSocket, being able to do that bidirectional communication without having to do HTTP requests or anything like that. You could go so far as to do XML HTTP requests, but I think one of the coolest ones that's just landing now is the WebRTC API. WebRTC API allows you to get access to your camera and microphone, but also provides all of the APIs you needed to do peer-to-peer connections to connect 2 or more users to each other and send data back and forth, so that right now we do this through Hangouts or through something else, but you could do that exactly through write your own Chrome app to do this. So really easy to be able to do that, same way as that you'd go through and do this as any other web app. Helden wants to know how you project your laptop screen to us without using the internet. So we have a rather fun kind of setup in our studios. I actually have to plug my laptop into a special box that gets plugged into another computer. We'll do I think we should do a hangout on how we do our hangouts sometime in the future. I think that would kind of be a little bit of a fun one. Fabs from Switzerland wants to know about the performance of Chrome mobile apps. And that's something that's really important to us. We want to make sure that these apps run beautifully, and that's why we're not ready to start sharing them with the world yet. One of the things that we're doing to really try and make sure that these apps run beautifully and these apps are great is we're investing a lot of time on Cordova. I mentioned this earlier, by having engineers work on Cordova, so they're actually submitting code to make Cordova better, as well as implementing some of the APIs, the Chrome APIs that aren't available today. So hopefully that answers your question, Fabs. Acflow from New York wants to know, can I use WebRTC, and are there any examples today? Yes, you can absolutely use WebRTC. Go hit up html5rocks.com, and I believe there's a couple working samples up there and a couple good tutorials that you can use to go through and figure out how to do these. one of the things that I just want to put up, we're almost out of time, so I'm going to just put up the link to the documentation again. So if you want to go find that documentation, any of the resources or anything like that, definitely go check that link out. Again, it's developer.chrome.com, and click on the link that says Chrome Apps.
Pete, could I just make a plug for a hashtag?
Absolutely.
So, I mean, if you guys want to have follow-on discussions on Google Plus or elsewhere, please use the Chrome Apps, all one word, hashtag.
Perfect. Yeah. So if you hashtag that stuff, we try and keep an eye on for those kinds of things and respond as best we can. There's also some mailing lists that if you want to get involved, you can have a look there. I'll add that as one of the comments afterwards in the Hangout video on our Google Plus page, on the Chrome Developers Google Plus page. So with that, so DJaz from Sweden wants to know, can I access the native menu bar or global menu bar in OS X in my app, or should I build my own with HTML and JavaScript? So DJaz, right now the answer is no. You can't access it. It is something we're trying to figure out how to do and how to get it to work right, because it's something that's really important to us. But we haven't been able to figure out how to get that to work right. Under certain operating systems and certain things, some things are restricted, and unfortunately that's one of them. So we're trying to see if it's something that's possible. I would recommend, for the time being, writing your own in HTML and JavaScript, but doing it in such a way that you know that if you're ready, if we do get it, you can quickly and easily remove it, and you're just calling a set of APIs. So I'm going to take one more question, and then we'll wrap up for today. And Dex, your question, you get to be the last one. Congratulations. Can Chrome apps run in the background be launched remotely? For example, tap a button on your phone, opens a full screen app on the desktop. It's an interesting question, and in many ways, yes. I haven't actually tried it, but theoretically, there should be no reason why you can't do that. So you remember before where we had our listen for launched listener in our main.js. There's no reason why you couldn't put a listener in there that listens on a WebSocket, listens on something else, that says, oh, when you hear this particular thing, great, open the new window. And I lied. I'm going to take two more questions because there's two more really good questions that I want to hit in here. The next question, why is local storage not available in Chrome apps? And is there any way to use a sync version of Chrome storage local in apps? Async read-write is a pain to work with. I agree with you on that pain to work with. Like I was struggling with it a little bit yesterday. But there are ways around it, and there's some good things that you can do. It's not available for a couple of reasons, and the primary reason being that local storage, being synchronous, is terribly slow. If you actually go and look at some of the analytics that people have done to see how fast it runs, it's actually one of the slowest things that you can do and slows down your app a lot. So by using async and forcing you to go that way, we're really trying to target on performance, making sure that your apps run fast. Ronnie, I hope that answers your question. I know it's a little bit fun, but there are some really good ways of being able to make it less of a pain, to put it politely. And then the final question, Ryan, in Connecticut, can I write Chrome apps, packaged apps using Dart? Not yet, but the team's working on it. It is something that a bunch of people have asked for, and it is something that we are working on. So, wow, that was an hour. There were a ton of fantastic questions, and there's a lot more really great questions in here. I'll try and take a look through these questions and respond to the questions in line over the next day or so. But if you see me on Google+, add me to your circles and keep an eye on me there. You should also add the Chrome developers to your circles if you don't already have those that in your circles, and follow that. So with that, I'll say thank you guys very much. This was wonderful. And Van, I'll pass it back over to you.
Well, thank you, Pete. This was a great inaugural GDG All Hands, and I'm looking forward to doing many more of these in the months ahead. Thank you, Pete.
Awesome. All right. Thank you. And thank you to everybody.